Hello viewers, welcome to CEC lectures. In this lecture series of Introduction to Programming in C++, till this point we have seen we have built the platform of function overloading, and in this lecture we are going to have a greater detail of this function overloading. Now in the previous lecture what we have seen, we have taken apart from all the theoretical aspects of function overloading, we have taken just one simple example of function overloading in which there was only one parameter and we have seen one program over there. Now here in this lecture, or in I can say in today's lecture, we are going to have some more details about this. So the first program which I am going to begin with today is how we are going to tackle more than one parameters in case of function overloading. So here I have taken an example of function with two parameters. So let's see this program which is available on the screen. So we have a function display. The return type of display is void and it is taking two parameters. One is variable 1 of type integer, another one is variable 2 of type double, and actually as the name indicates it is display. It is doing nothing but it is displaying the two variables. It is taking the first variable var1 cout and it is displaying the second variable which is variable 2 and it is through the print statement it is differentiating between integer number and the double number. That's what it is doing. It's a simple function. Now coming to the we can say one more version of this display which is taking only one parameter variable and one variable with the type var, and it is taking double. So it is of type double, so it is taking a double number and it is displaying it. So now we have two versions of display, one with integer and double, another one with only double. And in the next version of display we have taken, which is again a kind of we can say overloaded function. So we are taking display and int var. So this is taking one integer variable and displaying it as an integer variable. So basically if you can try to consolidate this program till this point, we have three versions of display. One is taking two parameters, one is integer, another one is double. Another the next version of display, or the next overloaded version of the display function, is taking one variable which is of type double, and the third overloaded function named as display is taking only one variable which is of type integer. So basically three overloaded versions of display till this point we have seen. Now what are we going to do in main function, or how are we going to call it? So I have taken two values. One is a, which is equals to 5, it is of type integer. Another one is b, which is 5.5 and it is of type double. So now we are having two parameters, and let's see how are we going to use it. So if I am going to pass only one parameter which is a inside the display, in the second call to display I have taken only one parameter which is b, and in the third call to display I have taken both the parameters a and b, and then finally a return 0. So the first function call is only with one integer type parameter, second function call is with one double type parameter, and the third function call is with two parameters which is shown here with is the name as display a comma b. So I mean it's very simple to guess that what actually is happening inside, that when we are saying display a, it is taking a as an integer number. It's an integer number and it will call the function with integer type parameter. When I am saying display b, it is going to call the function with double type parameter, and when I am saying display a comma b, it is going to call the function with both the parameters. So here if you can see, all the three overloaded functions have been called, or we can say have been used. If you can see, drill down into the working, when display a has been called, the version having an integer variable has been called. If I am saying display b, then an integer, then the version of function display with the variable with a double variable has been called. And when I am saying display a comma b, it is obvious that the version of display with variable 1 and variable 2, two variables has been called. So this is what is actually kind of, we can say a matching algorithm or a matching process is taking place inside. So how this if we want to see into kind of with a microscopic lens, that how this function overloading is actually going to work. So this is, we can say, it's a sequential process, or it's a sequential step. So first of all, your compiler will look for the exact match. So whenever I am saying about exact match, that means the function name and parameter, as well as the number of parameters, not only the types of parameters, but the number of parameters, types of parameters, and the function name. So exact match has been found. Exact match has been found between who? So exact match has been found between the function call and the function definition. The function definition, if you can see here on the screen, the function definition is written above, and within the main we have three functions calls. So the first function call says display a. So it will look for a version which will which will match with this call. When I am saying display b, it will look for the version which will match with this call according to the number of parameters. And as I have told you in the previous lecture, that it is only number and type of parameters which is going to differentiate. Alone the return type cannot differentiate between the overloaded functions. So if it is only return type which is different, you cannot say the functions are overloaded. Similarly, if I am calling here display a comma b, then obviously that kind of match is being looked for. Now there can be situation when there is no exact match. So I mean, a call is saying something while the definition is saying the something other, and the system or the compiler, I can say, is not able to find any exact match. So now what will happen in that particular case? So let's see. If no exact match has been found, then it will try for kind of automatic promotions, we can say. So what kind of automatic promotions your compiler is going to try? For example, your character, unsigned character, and short, these three types of variables are promoted to int. This is also a kind of, you can say, automatic promotion or automatic conversion, we can say. This we have seen in the initial lectures of our series. Then we can say float is also being from the same family. Float is also promoted to double. Now after this kind of promotion of the variables, the compiler will again try to look for the match. So earlier it was looking for an exact match, so exact match has not been found, so it has kind of given some automatic promotions which are within the limits, we can say. So character, unsigned character, and short are promoted to int. Float is also promoted to double, and with this promoted parameters, now it will try to look for the version, or now it will try to look for the match of overloaded functions. Even if no match is found now after these two steps, so exact match is not found, and after the promotion, the we can say the match is not found. So what will happen? C++ tries to find a match through the standard conversion. So if both the steps fails, then it is going to give you an error. So it will try on its own, but if certainly nothing has been worked out, it is going to give you an error. Now if you can see, we can say in detail, many standard library functions which we are using on and off in C++ are overloaded. How? Now for example, let's take an example of the function sqrt. So if I am going to say sqrt4, it is going to give me obviously 2. If I am going to say sqrt 16.0, it's going to give me 4.0. So it depends on what kind of parameter I am passing. Then according to that parameter, as this function in the library itself is overloaded, the match will be found. If I am passing an integer function, it is going to take an integer kind of integer version of sqrt function. A version in the sense the version of the sqrt function which is having integer parameter. Now here with the help of in the case of sqrt function, it is very clear that we are talking about the one parameter only, so it is not going to change. Return type is something which we actually we can say we don't care about, because return type is not the criteria which is going to make the call of the overloaded function differentiate, at least on the base alone. So number is same. In case of sqrt, there has to be only one parameter, right? So what is going to be different? It is only the type of parameter here in case of sqrt which is going to be different. So this sqrt can take an integer, this sqrt can take a float variable, this sqrt can take a double variable, and on the we can say on the basis of what type of parameters we have, what type of parameter we have given to this sqrt function, it is going to call the appropriate version, and then you are going to get your result. So how this has happened? So this is just possible because sqrt function is overloaded in C++. Now think of some other functions as well. For example, print function. So print function, if you give something in double inverted commas, it's going to print you that particular thing as it is. That's an string. Fine. Now what about if you say cout x? What will happen? It is going to give you the value of that variable x, assuming x is a variable. So passing x within double inverted commas is going to give you x, and passing x without double inverted commas is going to give you the value of that variable x. So what do you think? What is actually kind of being happening here? Here it is nothing but this all scenario is possible because all these functions are overloaded in C++. Now in let us try to see that what we have covered till this point in the lecture, that we have seen how this overloading actually work, and we have also seen the example of overloaded example of an overloading program with 3 versions of one overloaded function. So that overloaded function is differing in the case of types of parameters as well as number of parameters. So in one version we have given 2 parameters, and in another 2 versions we have given single parameter but different in each type. So we have I can see I can say that we have seen the function overloading into a greater detail, and we have also seen that, we have also recall that, try to connect that it is not only the user defined functions which are overloaded, but many standard library functions are also overloaded, and we have taken a couple of examples for this also. So now moving forward from here, let us try to understand what are the rules for overloading. So the first rule which is there is, if there is a function which is overloaded and it is differing only in the return type. For example, if you can see the following program which is written on the screen, this program is going to fail in compilation. Now why? Because as per the rule, it is not only the return type which will be able to differentiate between the overloaded versions. So for example, here is a program which is having two versions. One is returning an integer number, another one is returning a character. Both these functions are named as foo, and there is no parameter list. That means the parameter list for the first foo is empty and parameter list for the second foo is also empty. The only differences of the name, obviously we are looking for the same names when we are talking about overloading. The only thing which is different here is the return type. So the first one is having return type of integer, another one is return type of character. Now what will happen if I am going to call these functions, for example character x is equals to foo or something of that sort. So the point here is it is not going to compile even. This program fails in compilation because your compiler, as I have told you that function overloading is a compile time polymorphism. At the time of compilation, your compiler tried to we can say have the binding between the call and the version. So in order to there is an ambiguity because your compiler is actually looking for what? Your compiler is, in case of an overloaded function, your compiler is actually looking for the difference either in the type of parameters or in the number of parameters. So here in this example there is no parameter list. So parameter list is 0. Name is, we are looking for the same name. So what what is being deferred here? If you see in this program, the difference here is only and only the return type. So first one is having a return type of integer, another one is having a return type of character. So this program is going to fail the compilation. This program will not compile. Now another rule of this function overloading is member function declaration with the same name and the name parameter type list cannot be overloaded if any of them is a static member function declaration. So if we have static, as I have already told you that static functions cannot be overloaded. So here if you can see, we have two functions with the same name. The name is fun and the data type is same, as well as the we can say parameter list is also same, only one parameter I, that too of type integer. But what is the difference between these two functions? One is a member function as it is written inside the test class test, and another one is a static member function which is not we can say it is not related to any of the object, and this we have seen in our earlier lectures which dealt with this static function. So one is a static functions and another one is a member function with the same name, same parameter list and same return type as well. So this program will also fail to compile. It is not going to get compile. So even if we write a main function here which says we are making an object of the class test t, and then so even this object creation will not be successful because it is not, the program is not going to get compiled. So basically two rules here as of now, that it is not the only we can say the return type which will be able to differentiate between the overloaded functions, and the second rule here is static functions and the member functions with the same name cannot be overloaded. Now let us try to explore some more rules about this. Then coming to the parameter declaration. Now if there is a parameter declaration that differs only in a pointer versus an array. So for example, one parameter declaration is taking pointer and another parameter declaration is taking an array. They are considered as equivalent. They are not considered as different overloaded functions. So because, now what is the reason behind this? Because the array declaration is adjusted to become a pointer declaration. So only the second and the subsequent array dimensions is significant in terms of parameter types. Now what I am trying to say, let us establish this with the help of a function prototype. So here if you can see on the screen, there are two function declarations. One is an integer function fun returning an integer type and taking an integer pointer ptr, right. Another one is an function returning the integer type with a integer, with a array of integers named as ptr. So what is actually kind of taken here? It is actually a kind of redeclaration of the previous one. So one which is taking the array is considered as redeclaration of the previous one which is having pointers. So array declaration is adjusted to become a pointer declaration, and only the second and the subsequent array dimensions are significant in parameter types. So these two declarations or these two prototypes are considered as equivalent. So if we are going to fall trapped into some such situation in which within the parameter list there is only difference of your parameter in terms of pointer and in terms of array, it's not going to solve the purpose of your function overloading. Now another rule, parameter declarations, two parameter declarations that differ only in their default arguments are considered as equivalent. For example, we are going to see an example in a moment that is also going to fail in compilation. Now how? Let's see. So here is a kind of, we can say we have a function named as f. It is having two parameters, one is integer x, another one is integer y, and it is returning an integer value, and that integer value is nothing but x plus 10. So what is what is being passed in x will be incremented by 10 and will be returning. The second, which is the overloaded definition of this function f, is also a definition or also prototype I can say, which is taking integer x and taking a default argument y as 10 and returning an integer also, and it is returning x plus y. So try to notice the difference between these two functions f. One is having two variables, another one is also having two variables, but among them one is a kind of, we can say, default argument which is contained in the second. So even if I am going to kind of try to compile this kind of we can say function, it is not going to help us because these two are not distinguished by the compiler. So here we have to be very careful if we are using these default arguments. Now default arguments are actually, we can say, are having a different kind of say or insight when it comes to overloading. So let us try to explore this as a kind of different matter of fact. So what actually happens with default arguments and overloading? In some situations your default arguments can be used as a shortened form of function overloading. Yes, you heard it right. In some situations your default arguments can be used as a shortened form for function overloading. Now how this can be taken up? Let's see. So here we have a class which is named as cube, and it is having three variables x, y, z with a public constructor which is named as cube. I am naming the variables as integer I is equals to 0, integer j is equals to 0, and integer k is equals to 0. And what is happening inside the function is I is given to x, j is given to y, and k is given to x. So here you can witness this example here on the screen. One class cube, then the constructor, and within that constructor there are some default arguments, and the value of these default arguments is being passed to member variables. This is what is happening here. Now in the we can say, if we are going to use this function anywhere else, how are we going to use this? So there is a volume function which is returning some x multiplied by z. So if you can see the clever call here, there is call to the, we can say, constructor in the form of object creation. So as you all are aware that whenever an object is being created, a constructor is being called. So here we can say cube, which is kind of, we are trying to create two objects of this class cube. So these two objects, one is named as A, another one is named as B. As you can see on the screen, the program is shown here. So whenever we are saying A, the parameters are being passed 2, 3 and 4, and when we are saying B, no parameter is being passed. Now what is happening here? If you can see, whenever we are saying A, 2, 3, 4, then the previous default arguments of the constructor will be replaced by the new 2, 3, 4. So here in this screen, if you can see, integer I is equals to 0, integer j is equals to 0 and integer k is equals to 0. This I, j, k which are being set as 0 in the default situation will be replaced by 2, 3 and 4, and according to these value of 2, 3 and 4, the volume will be calculated. Now in the second situation, whenever I am talking about creation of an object with just B, so what will happen? Again the constructor will be called, but in absence of any parameter list, the value of I, j and k will be taken as their default value, which is nothing but 0 for all the three, as our program shows us. So now what is actually happening here in this program, that we have cleverly used default arguments as a shorthand to I can say function overloading. So constructors here are I can say overloaded whenever there is no parameter passing. The default value of the variables will be taken. Whenever there is a parameter passing, that particular value will be replacing the default value, and accordingly. So A dot volume, when I say A dot volume, this is obviously going to give me 2 into 3 into 4, which is nothing but 24, and whenever I am talking about B dot volume, this is going to give me just 0, because in this situation the old parameters are working. So here, if let us say we try to recapitulate or summarize this lecture, what we have seen here is, we have seen overloading into a greater detail with different number of parameters. Then we have seen what are the rules regarding this overloading procedure, and what is the kind of, we can say, importance of default arguments, particularly in case of function overloading. And here is a list of references which is being used for the preparation of this lecture. Hope you have enjoyed the lecture. Thank you for a patient hearing.